In this video, we're looking at problem sum 9 from exercise 10.2 from the chapter Circles. Let's begin with the problem statement. In figure 10.13, xy and x dash y are two parallel tangents to a circle with center O. So, xy and x dash y, they're parallel to each other and tangents to the circle with center O, and another tangent AB with point of contact C. So, AB, this is the point of contact C, intersecting xy at A. So it intersects xy at A and x dash y dash at B. We have to prove that angle AOB is 90 degrees. So which angle? This angle, right? This angle here is a 90 degree angle. So since it's pretty straightforward, they had already given us the diagram. What I've done is I've already written the given and to prove. And now let's look at the proof. So in order to prove that angle AOB is 90 degree, what we really have to do is that we have to prove that this angle, that is angle POA, is congruent to angle AOC. And we can easily do that by using RHS, proving that triangle APO, right, this triangle here, and ACO, this triangle here, they are congruent to each other by RHS, and by CPCT we can say that this pair of angles is congruent to each other. Then you have to prove that this pair of angles is congruent to each other. For that we just have to by RHS show that this triangle, that is COB and BOQ, these triangles are congruent to each other. Okay, and once that is done, we simply have to consider the angle, the linear angle POQ, okay, which is the sum of all of these angles, right? And also, since it is a linear angle, the sum of all of these angles is nothing but 180. So if you just substitute what we will have proved, that is by CPCT, that these two angles are equal, if you just substitute that, you will automatically reach to the conclusion that angle AOB is 90 degree. Okay, so it's very simple, just lengthy. You'll have to just write a lot in this. So let's just begin by proving the first pair of triangles is congruent. So in triangle APO and triangle ACO, angle P is equal to angle C is equal to 90, radius perpendicular to tangent, that is our theorem 10.1. OA is equal to OA, which is also the hypotenuse of these right angled triangles, and since it is the common side, it is the same for both the triangles. Also now OP is equal to OC. Why? The radii. Therefore triangle APO is congruent to triangle ACO by RHS. Let me just mark it for you, right? This is 90, and also the radius is equal to the radius. Okay, therefore I can say that angle POA is equal to angle AOC by CPCT. Mark it as 1 so we can use it later. Now let's prove the next pair of triangles, BOQ and triangle BOC. Angle Q is equal to angle C is equal to 90. Why? Radius perpendicular to tangent, that is theorem 10.1. OB is equal to OB, common side, OQ equal to OC, the radii. Therefore triangle BOQ is congruent to triangle BOC by RHS. Therefore, by CPCT, I can say that COB is equal to QOB by CPCT and mark it as 2. Alright. Again, let me just mark it for you. So, OC is equal to OQ. They are the radii. OQ is perpendicular to x dash y dash by theorem 10.1. OC is perpendicular to AB, and OB is the common side. Alright, so we have proved that the angles POA is equal to angle AOC and angle COB is equal to angle QOB. So now let's look at the linear angle POQ. So I know that POQ, it is actually the sum of angles POA plus AOC plus angle COB. But the measure of a linear angle is also 180. Okay, and now you must have also figured out that where am I headed to. So we are actually interested in angle AOB, and so we really can get rid of this angle and this angle. How? By using our conclusions 1 and 2. So if we simply substitute for POA by AOC and BOQ by COB, we will automatically get our angle AOB. Okay, because POA is equal to AOC and COB is equal to QOB, we can easily substitute for them. AOC plus AOC, COB plus COB equal to 180. So twice of angle AOC plus twice of angle COB is equal to 180. 2 is common, so I take it out. Now, the sum of angle AOC and COB is our required angle AOB. So I'm going to write it as like this. What happens to the 2? The 2 goes to the other side. Since it is multiplied on the LHS, on the RHS, we will divide 180 by 2, and therefore angle AOB is 90 degree. Hence, proved. Alright, so if you have any doubts or questions, feel free to post them in the comment section. If you like this video, give it a thumbs up and don't forget to subscribe our channel for more videos like this. Thank you so much for watching this video.